Good morning. I'm Mary Joseph and I'm an MCA student at Marvin College, Kuttakaram. Today I'm going to present on the topic designing a hashing strategy for fast student attendance. In this presentation, I will explain how hashing can be used to quickly store and retrieve student attendance record. I will discuss the real world problem, the, the need for a data structure, the working of hashing, algorithm steps, an example, time and space complexity, and finally conclude the topic. In educational institutions, teachers need to mark and check student attendance regularly. When the number of students is large, searching attendance manually from a register or list becomes slow and inefficient. So we need a faster and more efficient method to manage attendance records. Why use a data structure? When we use a simple data structure like arrays or list, searching happens sequentially. For example, with 100 students on average, we may need to check 50 records. This approach does not scale well. What what works for 30 students becomes inefficient for 300 students. To solve this scalability issue, we use a hash table which allows almost instant searching, insertion, and updating. What is hashing? Hashing is a technique that converts a key into an array index using a hash function. In this case, the key is student's register number. For an example, a register number like 25PNC137 is converted into a numeric index. That index directly points to the location where the attendance data is stored. The biggest advantages of hashing is direct access, which completely eliminates searching. Hash table structure. A hash table stores data in the form of key value pairs. Here, here the key is student's register number and the value is the attendance status, either present or absent. Each student record is stored at a specific index in the table. This allows quick references because we can directly access the record without scanning the entire list. Next, we have to see the hash function. To calculate the table index, we use a simple hash function based on the modulo operation. The formula is index is equal to register number modulo table size. For an example, if the register number is 205 and the table size is 10, 205 modulo 10 gives 5. So the attendance record is stored at index 5. This ensures that every register number maps to a valid index. Let's look at the steps of the algorithm. First, we initialize a hash table with a fixed size. Next, we extract the student's register number as the key. Then we apply the hash function to compute the index. After that, we store the attendance status at the calculated index. Finally, for retrieval, we apply the same hash function and directly access the stored value. For basic operations, insertion and search both use the same hash function. We calculate the index and directly store or retrieve the attendance status. However, sometimes two register numbers may map to the same index. This is called This is called a collision. To handle collisions, we can use technique like chaining where multiple values are stored using linked list or linear probing where we search for the next available slot. These strategies ensure that data is not lost. On average, hashing provides order of one constant time performance, which makes attendance lookup extremely fast. The space complexity is order of n as storage grows with the number of students. In the worst case, performance can degrade to order of n if there are many collisions, but this can be minimized with a good hash function. Overall hashing transforms attendance management from a slow sequential process into, into an efficient and scalable system. With proper design, it works efficiently even for large student populations. Thank you for watching. I hope this presentation was informative.